Welcome to today's class. In this class, we are discussing two more problems. These two problems are little bit different functions compared to what we discussed already all the previous classes. Okay. First problem is all written on the board. The problem is find f of x is equal to root of 1 minus cos x for x greater than 0 less than 2 pi in a Fourier series, and hence evaluate 1 by not 1.3 is 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7, etc. I want to evaluate this value. That you know that how to evaluate a deduce from the Fourier series. Once you give a particular value of x, then automatically we get the required deduce part. Here instead of deduce, they are asking what's the value of this series. Now first we have to find out what's a Fourier series for the given function. First we have to consider what is given. Given is actually given f of x is equal to root of 1 minus cos x over the interval 0 to 2 pi. Okay, over the interval what actually 0 to 2 pi. Now this is one of the important problem. Now how to do it here. Now here this is not as usual function. Suppose you construct a Fourier series. What is my overall interval here? 0 to 2 pi. It's referred to the which case? First case what we discussed in the class, 0 to 2l. That implies what's the value of L is 2 pi is equal to 2l. That implies what is L is pi. L is pi, that implies n pi x by L is nothing but what? Nx. Pi cancel. Now it's referred to the first case, we can't go for even or odd. Now, but before going to construct the Fourier series, first try to simplify for this because integration of root of 1 minus cos x is not easy. Therefore, you already know that what is 1 minus cos 2x? 1 minus cos 2x is nothing but 2 sin square x. This is a fundamental formula. First, try to remove the square root, then easy to evaluate. If how to remove the square? First, try to express 1 minus cos x in terms of the square of the function. Therefore, this implies what is 1 minus cos x. Cos 2x half of that. Cos x half of that is sin square of x by 2. Now, the given function can also be written as root into sin square of x by 2. What we get? Root 2 into sin of x by 2. Now, sin of x by 2 is easy to evaluate. Now, I have to leave it as itself. Now, I have to write what is Fourier series for the function Fourier series for f of x equal to what? Root of 1 minus cos x over what's the interval 0 comma 2 pi is. I go for first case, therefore f of x is equal to what actually a naught by 2 plus summation in ranging from 1 to infinity a n cos of nx. You already simplified that. N pi x by L is nx plus summation in ranging from 1 to infinity bn sin nx, where what is a naught formula? 1 by L, 1 by pi, 0 to 2 pi, 0 to 2L, f of x dx. What is a n formula? 1 by pi, integration of 0 to 2 pi, f of x into cos nx with respect to x. And also similarly, what is the formula for a bn is 1 by pi, 0 to 2 pi, f of x into sin of nx with respect to x. Yeah. Next, we have to find out 1 by 1 for a naught. Instead of taking root of 1 minus cos x, I have to take what's the function? Root 2 into sin of x by 2. First, I have to find out a naught. A naught equals 1 by pi, 0 to 2 pi. What's the function? Root 2 into sine of x by 2 with respect to x or dx. Root 2 is a constant, root 2 by pi. What is integration of sine minus cos of x by 2 divided by quotient of x? What is quotient of x is 1 by 2. What's the limit? 0 to 2 pi. While applying the limit, I have to keep the constant outside. What's the constant here? 2. This 1 by 2 comes in numerator. 2 into root 2 divided by pi. Minus sign also I have to keep it outside. Apply the upper limit. What's the upper limit? 2 pi. Cos of 2 pi divided by 2 minus cos 0. What is 2 to cos pi? What is cos pi is minus 1. You already know that this is nothing but minus 2 into root 2 divided by pi of minus 1 minus 1. Cos 0 is 1, cos pi is minus 1. What we get? Minus 2, minus into minus plus. Therefore, finally we get what is my A naught is plus 4. 2 into minus 1 is minus 2. 2 into 2 is 4. Minus into minus plus 4 root 2 by pi is the answer for A naught. Okay. Next, try to find out which value? AN value. Yeah. While finding AN value, I have to take care for this. For now, the formula for AN is 1 by pi, 0 to 2 pi. Yeah. While writing this function, root 2 is a constant, keep it outside. Sine of x by 2 into cos of nx with respect to x. Now how to proceed here? I go for transformation formula. First try to simplify. The transformation formula for this is 2, what about that, sine A cos B, sine A cos B, 2 sine A cos B. It's nothing but sine of A plus B plus sine of A minus B. What is my A here? X by 2. What is my B is nx. What is A plus B? A plus B is nothing but, that's very easy. Now I have to x by 2 plus nx. X is common, half plus n into x. And then A minus B. What is A minus B is nothing but half minus n into x. Just take x as a common factor. Now here we don't have a 2, therefore multiply and divided by 2. Therefore 1, 2 comes in denominator. Okay. Therefore root 2 divided by 2 pi. Are you clear now? Multiply and divided by 2 because 2 sin A cos B. For what we get? 0 to 2 pi. Now what's the function you have? The function is sine of A plus B means half plus n into x plus sine of A minus B. What is A minus B? Half minus n into x and then with respect to x. In the next step, root 2 divided by 2 pi of integration of sine. What is integration of sine? Minus cos of half plus n into x divided by quotient of x. What's quotient of x is half plus n. The limit is what actually? 0 to 2 pi. Again integration of sine is minus cos of half minus n into x divided by quotient of x is half minus n. What's the limit? 0 to 2 pi. I told number of times before going to apply the limit, observe what happens whenever having a trigonometric function sine or cos. First verify that what happened in the corresponding limit. Now I have to verify the corresponding limit. Now what happened? Now first I have to take cos of, what's upper limit? Pi. Cos of half plus n into 2 pi. Yeah, take 2 pi is inside the bracket. 2 pi by 2. What we get actually? 2 pi plus 2 pi by 2 is pi plus 2n pi. What is cos of pi plus theta? Minus cos theta. Cos of pi plus theta, you already know that cos of pi plus theta is nothing but minus cos theta. Therefore, minus cos of 2n pi. You already know that what's the value of 2n pi is minus 1 to the power of 2n. That is nothing but 1, we get minus 1. Similarly, cos of minus n into 2 pi. Now once you take 2 pi inside the bracket, we get pi minus 2n pi. What is cos of pi minus theta? Cos of pi minus theta is minus cos theta, cos of 2n pi. We get this also must be equal to same minus 1. Okay, fine. In the next step, I have to substitute upper and lower limit because in both the term is not equal to 0 for upper and lower limit. While applying upper and lower limit, better to keep the constant outside minus half plus n. Apply the upper limit cos of half plus n into 2 pi. After the simplification, what we get? Minus 1 minus cos 0. What is cos 0? Is minus 1. Minus 1 by half minus n as a constant. Now here I have to keep it outside. I think it's clear now. Minus. Now here apply the upper limit. Once you apply the upper limit, cos of half minus n into 2 pi is minus 1. Cos 0 is also minus 1. We get minus 2, minus into minus plus, minus into minus plus 2. Take 2 as a common factor from these two terms. Already 2 is there outside, is cancelled. We get root 2 pi pi. Yeah, 2 cancel. Yeah, once you take 2, then 2 cancel. What's the remaining now? 1 by half plus n plus 1 by half minus n. Okay. Now here, before moving to the next step, half, I'm going to simplify. Take 2 in the denominator LCM, 1 plus 2n. This is 1 minus 2n. 2 comes in numerator. This 2 comes in numerator. Both the numerator having 2. Take it outside. What we get actually? 2 root 2 divided by pi of 1 by 1 plus 2n plus 1 by 1 minus 2n. 1 minus 2n. Okay. In the next step, you take LCM 2 root 2 divided by pi of, take LCM, what's LCM? 1 plus 2n into 1 minus 2n. What we get? 1 minus 2n plus 1 plus 2n. What we get actually? Plus 2n minus 2n is cancelled. The remaining is 2. 1 plus 1 is 2. No, 2 into 2 is 4. In the next step, this is nothing but 4 root 2 by pi into 1 by 1 plus 2n into 1 minus 2n. Yeah, I told number of times before moving to the next step, whether is true for n is equal to 1, 2, 3. How can you know that? Pick the denominator factor. What are the factor? 1 plus 2n equal to 0, one factor. Another one is, this is implies what we get, n is equal to minus half. Minus not included in a summation 1 to infinity. Therefore, move to 1 minus 2n equal to 0. That implies n is equal to half. Half also is not included because our summation start from 1 to infinity. Therefore, even though n is equal to half, we get 0. That's what about this fact? No, 1 by 0 is what? Infinity. But n is equal to, what's the n when a set of positive integers start from 1, 2, 3, etc. Therefore, we can't, we are not considered fractional value. Therefore, confidently write this is true for n is equal to 1, 2, 3. Please observe carefully here. Before moving to the next step, first I have to know whether an is true for n is equal to 1, 2, 3. How can you know that? Pick the denominator factor of n equal to 0. Once equal to 0, 1 plus 2n, we get n is equal to minus half. It's not in the range 1 to infinity. Again, I equate another one factor, 1 minus 2n is equal to 0, n is equal to half. N is equal to half is a positive value, but our summation start from 1 to infinity. This is also excluded. This is also less than 1. Therefore, confidently write this is true for n is equal to 1, 2, 3, etc. Okay. In the next step, this is nothing but my which value? En value. Next, I want to find out Bn. Once you finding Bn, what's the formula? 1 by pi. Then I have to keep root 2 also outside. Root 2 by pi. 0 to 2 pi. Sine of x by 2 into sine nx with respect to x. This is nothing but sine A, sine B formula. What is my sine A, sine B formula? Observe carefully. Now while taking this sine A, sine B, yeah, this is sine A, sine B. Yeah, you know that what is 2 sine A, sine B? Sine A, sine B is nothing but cos of A minus B minus cos of A plus B. Cos of A plus B. Now this is nothing but 2 sin A sin B. 2 sin A sin B is nothing but what? Half of cos of A minus B minus cos of A plus B. Now what we get actually here, what is my A is nothing but x by 2. What is my B is nothing but nx. In the next step, A plus B. What is my A plus B is nothing but half plus n into x. What is A minus B is nothing but half minus n into x. Just few minutes before we calculate now similarly. Okay, in the next step, this is nothing but root or 2 is not there, multiply and divided by 2. Therefore, we get 2 pi 0 to 2 pi. Okay, 0 to 2 pi. What is this is nothing but sine of, sorry, not sine, cos of A minus B. Yeah, just a minute. This is nothing but cos, not sine. Yeah, 2 sine A, sine B is nothing but cos of A minus B of minus n into x minus cos of A plus B of plus n into x with respect to x. And then I have to evaluate this integral. Yeah, you know integration of cos is what? Sine. Now root 2 divided by 2 pi of integration of cos is sine of minus n into x divided by quotient of x of minus n. What is my limit is 0 to 2 pi. Okay. Minus again integration of cos is sine of plus n into x divided by quotient of x is of plus n. What's the limit? 0 to 2 pi. Okay. Next we are going to apply upper and lower limit. Before going to applying upper and lower limit, first observe what happened for sine upper and lower limit. Now I'm consider now sine of minus n into upper limit is 2 pi. Once you take 2 pi inside the bracket, 5 minus n pi. What is sine of pi minus theta? Sine of, sorry, this is 2n pi. Yeah, once you multiply that, we get this is 2n pi. Okay. What is sine of pi minus theta? Sine of pi minus theta is sine theta. Means sine of 2n pi. What is sine of 2n pi value? 0. Similarly, sine of plus n into 2 pi is nothing but sine of pi plus theta. Theta is 2n pi. Take 2n pi inside 2 to cancel. What is sine of pi plus theta is minus sine theta. But what is sine of 2n pi value? 0. And also sine 0 is 0. Observe both the term is involving sine. Upper and lower limit value 0. Therefore, confidently write these two terms are 0. Therefore, Bn is 0 for n is equal to 1, 2, 3, etc. Yeah. Next, we have to construct a Fourier series. Yeah. F of x equals a naught by 2. What is my a naught? A naught is 4 root 2 divided by pi. A naught by 2 is 2. 4 is cancelled to 2 root 2 divided by pi. Yeah, a naught is actually 4 root 2 divided by pi. Therefore, 2 root 2 by pi plus, while writing an, just few minutes before we calculated what is my an. Now, while writing an, now what we get actually? Now, observe carefully. Now, while writing this an, I'll do it one the simple simplification. Instead of 1 minus 2n, I'm writing 2n minus 1. What we get actually? We get a minus sign. Now, this can also be written as minus 4 root 2 divided by pi divide. Now I'm going to take this. This is a part for this 2n plus 1 into, or if you want to write 2n minus 1 first and 2n plus 1 second. Okay, fine. Okay, 2n minus 1 into 2n plus 1. Observe carefully what I did here. This is also correct. Now, for our convenience, because once you give a n is equal to 1, 2, 3, we get negative value. Okay. Why don't you convert into positive value once you put n is equal to 1 to 3? Therefore, how we have to convert? Take minus n outside. 1 minus 2n becomes 2n minus 1 into 2n plus 1. You have a minus sign. Once you multiply that, we get same thing. Okay. While substituting that, what's a constant here? 4 root 2 minus 4 root 2 by pi is a constant. Better to keep it outside before going to substitute the value of en. Now I have to keep the constant outside, minus 4 root 2 divided by pi, summation in ranging from 1 to infinity, 1 by 2n minus 1 into 2n plus 1. Don't confuse why I have taken minus n outside. Once you take minus n outside, you give the value of n is equal to 1, 2, 3, we get positive value. That's why I taken, because our deduced part, if you don't have a negative value, have 1 by 1 into 3, 1 by 3 into 5 like that. Okay? That's why what I did, I take a negative sign outside from 1 minus 2n cos of nx, because bn is 0, therefore entire the summation is 0. But what is our deduced part? Deduced part is, they are not asking deduce, hence evaluate 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7, etc. I want to find out this series value. Actually, is the required Fourier series for the given function over what's the interval 0 to 2 pi. Yeah. Okay, fine. Now I want to deduce this. How to deduce that? Now you compare that. Suppose you expand this summation, this 1 by 2n minus 1 into 2n plus 1, what happened? Put n is equal to 1. What happened? 2 minus 1 is 1, 2 plus 1 is 3. Yeah. Put n is equal to 2. 4 minus 1 is 3 into 4 plus 1 is 5. Yeah. Next, put n is equal to 3. 6 minus 1 is 5. 6 plus 1 is 7. 5 into 7. Yeah, it look like this summation required evaluating the series only. But we don't want cos nx. I have to convert cos nx must be equal to 1. I want to retain this. I don't want this. Therefore, what's our my range? 0 to 2 pi. Therefore, what we are going to take? Put x is equal to 0. What is cos 0 is 1. Now here in the next step, yeah. Now here keep in mind what is my f of x is actually root 2 into sine of x by 2. Okay. Now in the next step, what we are going to do, if for our convenience, take it as star for this Fourier series expansion. Put x is equal to 0 in star. I think clear why I had to put x is 0, because I want to convert cos nx must be 1. We get f of 0 equals 2 root 2 divided by pi minus 4 root 2 divided by pi, summation in ranging from 1 to infinity, 1 by 2n minus 1 into 2n plus 1, since cos of 0 is 1. Now what is my f of 0? Root 2 into sine 0. What is sine 0? 0. Therefore f of 0 is 0. So this is 0. What I'm going to do, I'll take you this negative term in the left hand side. What we get, 2 root 2 divided by pi. No, either you write LHS first, RHS second, does not matter, because once you shifted this term in this left hand side, I'll write it, this is first, must be equal to 4 root 2 divided by pi of, we expand this summation. What is expansion of this? Just now we verified 1 by 1, 1 into 3, 1 by 3 into 5, 1 by 5 into 7, etc. Now before moving to the next step, I have to simplify. Observe carefully, root 2, pi cancel here. 2 ones are 2 twos are. Therefore, what's the value of this is actually after the simplification, 1 by 2 equals 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7, etc. This is a value of the given, the required evaluate part. What's the value we get? 1 by 2, because pi cancel. Root 2 cancel, then what we get actually 1 by 2 is the answer. Now this is a way to solve the problem. Suppose function is not in the standard form. What's the function they given? Root of 1 minus cos x. First you simplify, first you convert in the standard form for the evaluation of the integral, and then have to proceed. This is one of the different problem, and also don't confuse whenever they are asking the evaluation part, not 1.3, 1 into 3, 3 into 5, 5 into 7. Whenever they put dot between the two numbers, that is a multiplication between that, especially for deduced part in Fourier series. Now I move to the next problem. This is a way to evaluate this, okay? Now I told this, I think everyone is clear how we get the evaluate part. Why I taken the value of the value of x is equal to 0. That part also I explained. Okay, I move to the next problem. Today's second problem. Obtain the Fourier series of f of x equals L minus x for 0 less than equal to x less than equal to L, 0 for L less than equal to x less than equal to 2L. Hence, reduce that 1 by 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus etc. equals pi by 4. Reduce part, once you give the particular value of x, suitable value of x in between the range, the given range, given limit, then automatically we get, first you have to construct the Fourier series for the given function. This is my given function, okay? Solution. What given function here? The given function is f of x is equal to L minus x for x lies between 0 to L, 0 for x lies between L to 2L. Whenever they given in splitting function, you know that how to take our overall interval. What's overall interval is 0 to 2L. See, whenever start from 0 is referred to the which case? First case. What's our first case general interval? Also 2L only. Therefore, now here L is equal to L only. And sin pi x by L is nothing but sin pi x by L only, because the value of L is equal to L. Now I have to construct the Fourier series based on the first case. Fourier series Fourier series. Keep in mind, Whenever start from our interval is 0, refer to the which case? First case. Fourier series for f of x over interval 0, comma 2l is f of x equals a naught by 2 plus summation in ranging from 1 to infinity a n cos of n pi x by l, and then summation in ranging from 1 to infinity bn sin of n pi x by l with respect to x. No, see, not x. Yeah, 1 to infinity bn sin of n pi x by l, where now I have to write the formula for a naught, a and bn. A naught is 1 by l 0 to 2l f of x dx. What is my an? 1 by l 0 to 2l f of x sin of not sin, cos of n pi x by l, because here 0 to 2l only the limit, just like a first case. And then bn, what is my bn formula? 1 by l 0 to 2l f of x sin of n pi x by l with respect to x. Next, try to find out the values of a naught, a and bn using the given function. Now here is a refer to the first case, means you can't go for even or odd. Keep in mind the end of the Fourier series, don't confuse. Whenever our limits start from 0, you can't go for even or odd case. Directly have to write the Fourier series formula, and also write the formula for a naught, an, etc. Now what is a naught is 1 by l, but here is a splitting function. Therefore 0 to n, what's the function you have? L minus x with respect to x. L to 2l, what's the function you have? 0 into dx. Now we have to neglect for this because integral value itself, the function itself 0, therefore integral corresponding integral value 0. Now here most of the students simply they integrating L and X. I told in my previous videos, whenever having linear factor, you integrate using the fundamental integration. Integration of ax plus or minus b to the power of n with respect to x is nothing but ax plus or minus b to the power of n plus 1 divided by n plus 1 into the quotient of x is a. Like that. Now this L minus x can also be written as minus x plus L. Therefore, now what is the integration of L minus x is L minus x whole square divided by 2 into quotient of x. L minus x can also be written as minus x plus L. What's the quotient of x is minus 1. What's the limit? 0 to L. Okay. Now, while applying the limit, I have to keep constant minus 2 here is constant. Apply the upper limit. What is upper limit? L. X is L. L minus L. What is L minus L is 0. 0 whole square is 0. Minus lower limit. What is lower limit is 0. L minus 0. L minus 0 is L. L whole square is L square. You simplify that, we get A naught. What we get? L cancel, minus into minus plus. L by 2 is the A naught value. A naught is what actually? L by 2. Then next move to find out the value of AN. Yeah. How to find out the value of AN? That's AN again we are going to split the integral. 0 to 2L is nothing but what? 0 to L. 0 to L, what's the function you have? L minus x. Okay. L minus x into cos of n pi x by L, and then with respect to x, what happened? L to 2L is 0. L to 2L is 0. Entire the term must be 0. I'm going to neglect here. No need I to write the term. Yeah. Now 1 by L integration using UV rule or Bernoulli's rule. Which one is U function, which one is V function? This is U, this is V, because after the first derivative L minus X becomes constant. Okay. Now L minus X into integration of cos. What is integration of cos? Is sine of n pi x by L divided by quotient of x is n pi by L. Okay, fine. Minus, what is differentiation of L minus X is minus 1. Again integrate, what is integration of sine is minus cos of n pi x by L divided by, again we get n pi x, n pi by L, we get whole square. Once we get derivative value constant, not necessary to move further step. We are going to stop. Before moving to the next step, I told number of times whenever having a product of sine or cos, first you verify the corresponding upper and lower limit. Sine of n pi by L into L. What we get? Sine n pi. What is sine n pi value? 0. Similarly, cos of n pi by L into L upper limit. What we get? Cos n pi. What is cos n pi? Is minus 1 to the power of n. Therefore, now what we are going to write here? Sine, for upper limit sine is 0. Lower limit also what we get actually? Sine 0 is 0. The product must be 0. We are going to neglect this. Then minus into minus plus, plus into minus is minus 1 by L, yes, 1 by, while applying upper and lower limit, now L into, this becomes reverse, n square pi square divided by L square, 1 by n square pi square by L square means n square divided by n square pi square is a constant of apply the upper limit. What's the upper limit is L, cancel, we get minus 1 to the power of n minus 1. You simplify that, what we get, take minus n inside, what we get, L by n square pi square of 1 minus minus 1 to the power of n. Now this is our an. Before moving to the next step, I told number of times verify what happened for an for n is equal to 1, 2, 3. How to verify? Pick the denominator n factor. What is n factor? Is n square. N square equal to 0. When for which value of n is 0, n is equal to 0. But our summation start from 1 to infinity. Therefore, confidently write this is true for n is equal to 1, 2, 3, etc. And also another one point I discuss all my previous videos, whenever having inside the flower bracket, one of the term is 1, another term is minus 1 to the power of n. Commonly we get even case value and odd case value. One of the case must be 0. Then first I have to verify 1 minus of minus 1 to the power of n. Now take odd value minus 1, minus into minus plus. Whenever put n is equal to 3, put n is equal to 3, we get minus, minus into minus plus 1. Whenever I am going to give odd, if n is odd, what's the value is 2. Suppose n is even, minus 1 whole square becomes plus 1 minus 1 is 0. If n is even. Even cases, if you want to put n is equal to 4, minus 1 to the power of 4, 1. 1 minus 1 is 0. Now commonly we get this value. Therefore, before we move into the next step, first we are going to write the simplification form. Now commonly we get, for this is odd case 2, therefore 2L by n square pi square if n is odd. 0, because this is flower bracket 0 and the product must be 0 if n is even. Okay. Now this is a way, two simple way to find out a naught, an value. Next move to Bn. Bn is 1 by L of 0 to L. What's a function? L minus x into sine of n pi x by L. Not necessary to take second term L to 2L. What's a function? If of x is 0, 0 into sine of n pi x by L is 0. Enter the integral is 0. Then you go for UV rule. While taking UV rule, this is my u function, this is my v function, because after the first derivative, this is 0. L minus x is 0. Now from UV rule, what we get actually here from UV rule, okay, 1 by L minus x into what is integration of sign minus cos of n pi x by L divided by quotient of x is n pi by L minus what is derivative of L minus x is minus 1. Again at integrate we get minus sign of n pi x by L. Yes, sin of n pi x by L divided by the quotient of x is n pi by L, we get n pi by L whole square. What's the limit? 0 to L. We already known that in the previous finding an, sin is 0, put L, sin n pi we get 0, put lower limit is 0, the entire this factor must be 0. Therefore, not necessary to apply the limit, we already know that. But while applying L here, we get cos n pi is not equal to 0. In the next step, now to keep minus 1 by L, this L comes in numerator, L by n pi of upper limit. What is my upper limit is L. L minus L, 0 into cos n pi. What we get cos n pi is minus 1 to the power of n because L cancel. Minus x is 0, L minus 0. What is L minus 0 is L into cos 0. What is cos 0 is 1. Now what we get actually minus into minus plus, L cancel. This L is remaining L by n pi. Now this is one of the thing L by n pi, right? Observe carefully, L cancel, minus into minus plus, here having another one L, we get L by n pi. Yeah, this is 0. This is denominator 0, in which case n is equal to 0. But our summation start from 1 to infinity. Now confidently write Bn is true for n is equal to 1 to 3. Keep in mind, once we get n, Bn, first we have to verify for what value of n denominator 0. How can you know that? Pick the denominator n factor. What is n factor is n. N is 0, only 0 denominator, but 0 is not included in the summation. Therefore, what we are going to do here, we are confidently write is true for n is equal to 1, 2, 3. What is my next? I have to construct the Fourier series. F of x is equal to a naught by 2. A naught is L by 2. A naught by 2 is L by 4. While writing whatever that an, only we are going to consider an odd value. Even though taking odd value, keep the constant outside 2L by pi square. Only I have to take odd value, n is equal to 1, 3, etc. infinity. 1 by n square cos of n pi x by L plus yeah, what's a constant while writing Bn? We have L by pi, summation n ranging from 1 to infinity, 1 by n sin of n pi x by L. Now, here I want to deduce, what is the deduce part? This is the first I have to is the required Fourier series for the given function over what's the interval 0, 2L. The next step is I want to deduce some result. What's the result I want to find out now from the Fourier series expansion? I'm going to take this Fourier series expansion for our convenience, take it as star because I want to deduce some result here. Now, what is the deduce part here? The deduce part is 1 by 1 plus 1 by 3 plus 1 by 5. No, alternately minus sign. Yeah. Yeah. 1 by 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus etc. equals pi by 4. I want to prove this. Here 1 by 1, 1 by 3 like that. Here having two terms, one is two summation, one summation having 1 by n square, another summation having 1 by n. For which one I'm going to retain? This one I don't want this 1 by n square because our expansion is nothing but 1 by 1. Once you put n is equal to 1 by 1, 1 by 2, 1 by 3 like that. I don't want 1 by 1 square, 1 by 2, 3 square, 1 by 5 square. I don't want square of the each of the value. Therefore, this clearly I have to convert this summation must be 0. I have to convert this summation must be 0. But I want to retain this summation. But only I required, not for I required all the values. I required only odd values. I don't want 1 by 1, 1 by 2, 1 by 3. And also, in spite of that odd values, alternately I required plus, minus, plus, minus. Therefore, what's my overall interval? 0 to 2l. What I'm going to choose here, I'm going to choose x is equal to l by 2. Suppose choose x is equal to l by 2, what happened? Cos of n by l by 2. L by 2 means x is l by 2, L cancel, what we get? Cos of n pi by 2. Cos of n pi by 2 0 if n is odd. You already know that. Plus or minus 1 if n is even. Observe carefully, our summation is only odd values. In the odd value, what happened? Cos n pi by 2 0, what happened? This summation must be 0. Now put x is equal to pi, L by 2, what we get actually? Sine of n pi by 2. What is sine of n pi by 2? Root of this plus or minus 1 if n is odd, 0 if n is even. Yeah, that is suitable for our result. Result, they don't have any even value. They are having only odd values. Therefore, now from this, very clearly say that what is my L value is pi by 2. L is pi by 2. Please try to understand. Once you put L, x is equal to L by 2, cos n pi by 2 is 0 if n is odd. But summation is ranging from odd, entire summation, we are confidently at 0. Now sin n pi by 2 is, we get plus or minus 1 if n is odd. Therefore, I want only a plus or minus 1 in the odd cases only. Therefore, that is suitable. Therefore, we go for what's the value of L? Put x is equal to L by 2. L by 2 also in the range 0 to 2L. L may be 1, whatever may be. L is set of L is positive integer is already I told in beginning second class of my video class. Yeah. Now this is confidently I have to say that I have to choose any value of L greater than 0. Definitely L by 2 must be in the range 0 to 2L. In star we get, yeah, f of L by 2 equals f of L by 2 equals L by 4, yeah, 2L by pi square for summation in ranging 1, 3, etc. to infinity 1 by n square cos of n pi by 2 plus L by pi summation in ranging from 1 to infinity 1 by n sine of n pi by 2. The confidently I have to write this must be 0. I want to find out f of L by 2. What is my f of x? F of x is nothing but L minus x for x lies between 0 to L. 0 x lies between L to L by 2. Okay? L to 2L. L to 2L. L to 2L. Okay? Now, L by 2 is in the range 0 to L. Therefore, what is my f of L by 2? F of L by 2, definitely L by 2 is in the range 0 to L by 2. What is my f of L by 2? L minus L by 2. What we get actually? L by 2. Okay. Next, I have to substitute the value of f of L by 2 is L by 2. Okay. L by 2. Yeah. I take this is also in the right hand side. What we get actually minus L by 2 minus L by 4. This value is L by 2. I taken minus L by 4 in the left hand side. What we get L by pi. This is nothing but only odd value 1, 3, etc. to infinity. Then only we get plus or minus 1 value. In rest of the case for even cases for sine of n pi by 2 is 0. Okay. Now here 1 by n sine of n pi by 2. L by 2 minus what about L by 4? What we get? L by 4. Half minus 1 by 4 is 1 by 4 only. Yeah, take it up. Yeah, now observe carefully. L cancel. Take pi by pi as a cross multiplication. Now we get this implies pi by 4. Now take pi as cross multiplication. Pi by 4 is equal to expand this summation. 1 by 1 into sine pi by 2 is 1. Put n is equal to 3. What is sine 3 pi by 2 is minus 1 by 3. Put n is equal to 5. Sine 5 by 2 is plus 1 by 1 by n is equal to 5. And then put n is equal to 7. Sine of 7, 5 into pi by 2 is nothing but minus 1 into 1 by 7, etc. This is nothing but the required expansion. This is a way I to deduce the required result from the given function. I thought this is one of what about the different type of function. Overall interval itself 0 to 2L. How to choose the value of L? Keep in mind you compare the required result to the what you construct the Fourier series and then compare it and choose suitable value of L. You can't choose any value of X. Choose carefully, that value must be in the given interval only. Okay, I think it's clear everyone how to solve this problem using Fourier series expansion. Now, this is a way I think I covered all different type of problems explained. Now, if you want, I'll zoom out for this problem. The entire problem is look like, because once you zoom out, no, we get very uh, compact form manner. Now, I want to try to show that it's possible to show it entire problem in one screen. Yeah. Observe carefully here. Yeah, I can't zoom out more than that. Observe the entire problem in one screenshot. Okay, this is a way to solve the first, second problem, and also similarly first problem. Move to first problem. This is my first problem. Okay, still is not covered. I'll zoom out little bit. Yeah, because this is little bit lengthy problem. That's why. Yeah, this is our given problem. Now, once you zoom out this too much, you are not able to see. See, this is the entire problem in one screen visible, but it's not too font size is not too big. Observe carefully. Yeah, this is the entire problem. What I consider today first problem. This is second problem. This is second problem. This is first problem. Yeah, just I'll give 1 minute time. If you want to take a screenshot and then you have to keep that and write it, entire thing. Okay. Now move to second problem. I think it's clear. Thank you very much for listening my video. If we have any doubt, free to ask the question to take my mail ID from e-section. Okay. Bye. See you. Take care. Until I'll come and meet in the next half range Fourier series class.